Welcome to our deep dive into Bitcoin mining and the cryptography behind it. In this video, we'll explore how Bitcoin mining works, the role of cryptography in securing the network, and everything you need to know to understand this fascinating aspect of cryptocurrency. Let's get started. First, let's define what Bitcoin mining is. Bitcoin mining is the process by which new Bitcoins are created and transactions are verified on the Bitcoin network. Miners use powerful computers to solve complex mathematical problems, competing to add new blocks to the blockchain, which is a public ledger of all Bitcoin transactions. Now let's take a closer look at how Bitcoin mining works. 1. The blockchain. The Bitcoin blockchain is a chain of blocks, where each block contains a list of transactions. When a miner successfully solves a mathematical problem, they create a new block and add it to the chain. 2. Proof of work. The mathematical problem miners solve is known as the proof of work. This requires significant computational power and energy, making it difficult and costly to manipulate the network. 3. Hashing. Miners use hashing algorithms to convert data into a fixed-size string of characters, known as a hash. The Bitcoin network uses the SHA-256 hashing algorithm. The goal is to find a hash that meets specific criteria, making it challenging to achieve. 4. Competition. Miners compete against each other to be the first to solve the problem. The first miner to succeed broadcasts the new block to the network for verification. 5. Block rewards. When a miner successfully adds a block to the blockchain, they receive a reward, which currently consists of newly minted Bitcoins and transaction fees from the transactions included in the block. Now let's discuss the critical role of cryptography in Bitcoin. Cryptography ensures the security and integrity of Bitcoin transactions. It protects user data, prevents fraud, and secures the network against attacks. 1. Public and private keys. Each Bitcoin wallet contains a pair of keys, a public key and a private key. The public key is like an address that others can use to send you Bitcoins, while the private key is a secret that allows you to access and manage your Bitcoins. It's crucial to keep your private key secure, as anyone with access to it can control your funds. 2. Digital signatures. When you send Bitcoin, you create a digital signature using your private key. This signature verifies that you are the owner of the funds and prevents anyone else from spending them. The network uses these signatures to confirm the authenticity of transactions. 3. Transaction verification. When a transaction is made, it's broadcast to the network. Miners verify the transaction by checking the digital signature and ensuring that the sender has enough balance. If everything checks out, the transaction is included in the next block. Let's break down the mining process step by step. 1. Transaction pool. All pending transactions are collected in a pool called the mempool. Miners select transactions from this pool to include in the next block. 2. Finding the nonce. Miners add a nonce, a random number, to the block header and hash it. They repeatedly change the nonce and rehash until they find a hash that meets the network's difficulty target. 3. Difficulty adjustment. The Bitcoin network adjusts the difficulty of mining every 20x16 blocks, approximately every 2 weeks. This ensures that new blocks are added to the blockchain at a consistent rate, roughly every 10 minutes. 4. Broadcasting the new block. Once a miner finds a valid hash, they broadcast the new block to the network. Other miners and nodes verify the block and its transactions before accepting it. 5. Updating the blockchain. After verification, the new block is added to the existing blockchain, and the miner receives the block reward. As Bitcoin mining requires significant computational power, it has raised concerns about its environmental impact. Bitcoin mining consumes a substantial amount of electricity, leading to debates about sustainability. Miners often seek locations with cheap and renewable energy sources to mitigate costs and environmental concerns. Efforts are being made to explore alternative consensus mechanisms, such as proof of stake, which requires significantly less energy compared to proof of work used in Bitcoin mining. What does the future hold for Bitcoin mining? Advancements in technology may lead to more efficient mining hardware and software, lowering energy consumption and costs. Additionally, as more miners join the network, the competition will drive innovation in mining techniques. Regulatory developments may also shape the future of mining. Governments may introduce regulations aimed at reducing the environmental impact of mining activities, encouraging miners to adopt cleaner energy solutions. In conclusion, Bitcoin mining is a complex yet fascinating process that relies heavily on cryptography to maintain the security and integrity of the network. As the landscape evolves, understanding these concepts is essential for anyone interested in cryptocurrency. Thank you for watching. If you found this video informative, please like, share, and subscribe for more insights into Bitcoin, blockchain technology, and the world of cryptocurrency.